Hi, welcome to this video. In this video, I'm gonna show you guys a few examples on how to solve exponential equations. Okay, so in order for us to be able to solve these equations, we must be pretty comfortable with the laws of exponents. Okay, and we should also be comfortable exchanging an equation between exponential form and logarithmic form. Okay, so let's get started. For the first one, for the first couple of examples, we will be able to use a calculator because they want us to round our answer, find x, and we need to round it up to the nearest 3 significant figures. Okay, so we will be able to, we will have access to the calculator. So for part A, the first one is pretty easy. I have to find x, and since that's in my exponent, x is the exponent, I can have x, so I can just change this to a log form. I'll have log 5 to the base of 2, and that will be equal to x. And if you put that in your calculator, your x is equal to, your x is approximately 2.32. Right, 3 significant figures. Okay, now let's look at part B. Part B, 7 to the power of x plus 1 is equal to 16. Similar approach. I'm going to change this to logarithmic form. I'll have log 16 to the base of 7 is equal to x plus 1. So my x is equal to log 16 to the base of 7 minus 1. And if I put that in my calculator, my x is going to be approximately 0.425. Okay, approximately 0.425. Now, I want to show you guys something that's extra, right? Something that's more than what the question is asking us to do. So I want to play around with this line right there. I want to play around with that. Okay, so my x can be equal to log 16 to the base of 7. I want to express this in terms of just one log. Okay, one log of something, right? So this can be minus log 7 to the base of 7. And since I have a subtraction here, I can combine them. So here I have 2 log, right? I'll combine them as to the base of 7, but I'll have 16 over 7. So if, let's say today the question is asking us to find x, and your x should be one single log form, so that would be the answer. Okay, and if you use a calculator, your answer, if you put this in the calculator, you should also get approximately 0.425. Okay, the third one. In this case, I have e to the power of 3x minus 1 is equal to 3 to the power of x. Similarly, I'm going to try to somehow bring the exponents down, and I will try to use log, natural log, or log to help me to bring the x down from the exponent, right? So in other words, I could use ln. I'm going to ln the left and the right. Now, why do I go with ln? Because if I have ln, first of all, I can move the power to the front. I can move this power to the front, and then I would have 3x minus 1 ln e is equal to x ln 3. Now, what's ln e? ln e is equal to 1, right? So which means on the left hand side, I simply have only 3x minus 1. Now, for the 3x minus 1, which is the original exponent, when you bring it up to the front, make sure you put a parenthesis next to it, okay? Because without the parenthesis, number one, it's not correct. It's not exactly the same. Number two, students make mistake if they do that, all right? So 3x so let's continue. So 3x minus 1 on the left, on the right hand side, I have x minus 3. So I'm gonna bring that x minus 3 over. Minus x ln 3 is equal to 0. Let me bring the 1 over there. Okay. And then I'm gonna factor the x out. So I'll have x 3 minus ln 3 is equal to 1. So my x is equal to, so this is multiplication. So I will have to divide that to both sides. I'll have 1 over 3 minus ln 3. And if I put that in my calculator, my x would be approximately 0.526. All right, that would be, of course, I'm using a calculator for this. If the question does not allow us to use a calculator, then that could be your answer. All right, so that's it. Let's continue. The fourth one here looks a bit more complicated, but again, the x that we're trying to find, they are in the exponent. So I'm going to use the ln to help me out. For now, why don't we change it up a little bit? I'm going to take log to the base of 10. Log to the base of 10. So I will have, since it is multiplying, which means I can convert that to log 3 to the base of 10 plus log 2x is equal to log 4 plus log 5 to the power of x. Bring the power to the front. Bring the power to the front. I will have log 3 plus x log 2 is equal to log 4 plus x log 5. Something with x, something with x. Let's group them up. So let's have all the x's on the left, which means I'll have x log 2 minus x log 5 is equal to log 4 minus log 3. And I can factor the x out. I'll have log 2 minus log 5 is equal to log 4 minus log 3. My x is simply log 4 minus log 3, the whole thing divided by log 2 minus log 5. And if I put that in my calculator, my x would be around negative 0.314 approximately. Okay, now I'm going to, so that's it, that's the end of it. However, let's say if the question said no calculator, right? No calculator, so your answer could be that, or I'm gonna mess around with that a little bit. So my x is equal to, I have log 4 minus log 3. So if I have a subtraction, that means I can convert this part using the properties. That will become log 4 over 3, right? So I have log of 4 over 3 over, now that will become log of 2 over 5. So that could also be your answer. All right. Please do not do this. Log and log cancel out. 4 and 2 cancel out. That gives me 1. That gives me 2. We cannot do that. Please don't do that. Okay. We cannot do that. After we have converted the expression to what I have over here, and that's about it. We can't really do anything else with it. Okay. All right. In the next video, I will show you guys. I'll be continue to show you guys on how to solve exponential equations. However, we will no longer be able to use a calculator. In fact, my value of x must be in terms of a fraction, where the denominator is going to have ln a value of a, and the denominator will have an ln a value of b. So I'll see you guys in the next video. See ya.